Unfortunately, this is not a very long lecture today, and I know that that upsets a lot of you that I'm not going to show you a lot of demonstrations or examples today. We're just adding one component today. We spoke about Avogadro's number yesterday, the 6.02 times 10 to the 23. You get to use that today. Now, what's going to be fun about that is making sure that you can type that value in on your calculator. One suggestion that I would highly recommend, don't type in 602 and then 21 zeros after that. Okay, so we will use our exponent button today to type into 23. That'll just make things a lot easier, and I'll show you how to do that again if you've forgotten. Today we're actually going to convert the number of moles to molecules. Actually, I think I'll even take it from grams to molecules as well. And even, no, I think I even will go from grams to atoms. You will absolutely love it today. We will do this example when I turn the lights on. I don't know if there's any blanks or not for this.
Is that all of it?
Well, this part as well. We're not doing concentration today. Yeah, that'll be small. And again, there's no blanks on this part, but it's just showing you how to convert from molecules to atoms. The most important thing is whenever we're doing the factor labeling, whatever units we start with, if it's not the unit that we're looking for at the end, move it diagonally and cancel it out.
All right. Why couldn't you just have explained that when we did this the first time?
We did, or I did. Yeah. Numerous times, but hey, it's all right. And we will do this example as well. Let me turn the lights on here. Looking at the first example, look on page 6, where bottom half where it says how many molecules are in 3.98 moles of aluminum hydroxide. Now, before I actually get to the question, I want to talk about this sequence here. And this sequence is one type of sequence that you're going to want to know. Even though I have kilograms here, I could easily put milligrams, I could put nanograms, I could put micrograms, I could put picograms. The great Mega King one day caught me microwaving nasty pizza grams on there. Okay, so it's open to anything as long as it's a metric conversion. Now, one thing that we have to realize when working with this sequence is that the problem will give you something. Like for example, this problem gave us 3.98 moles of aluminum hydroxide. Okay, and the question wants to know how many molecules. Okay, so it wants to know how many molecules we have. So we're going to start here since it gave us our number of moles. This sequence goes one direction. Okay, we're not going to go backward to go forward. Since we start with moles and we're looking for molecules, we're going to go in that direction. Now, some of us might, for whatever reason, I don't know why, but sometimes students feel that they need to find the number of grams, but you don't need to, because if we start here and we're going to find the number of molecules, you don't need to find the number of grams. Okay? Sometimes I might give you the moles and ask you how many kilograms that is, then that's the sequence that we'll go. Whenever we use mole within the factor label problem, okay? If it's given to us, we'll probably cancel out mole to look for something else. We want to make sure that we have a value of 1 for our mole amount within the problem. So if I start with 3.98 moles, that's what we're going to start with, but eventually we'll cancel that out with the use of 1 mole. Also, when we convert between moles to molecules, how many molecules are in a mole?
That number you taught?
That number I taught you. Good. 6.02 times 10 to the 23. Your Avogadro's number. So if I start off with what I know, 3.98 moles, and I want to know how many molecules, what unit moves diagonally here? Mole, because we want to cancel that out. What value should I have for mole? 1, good. And then how many molecules are in a mole? Isn't that fun? And what is the unit that we're looking for in our final answer? Molecules. Now, if I would have given you a problem that looks something like this. If I wanted 3.98 mole, or I had 3.98 moles of aluminum, and I wanted to find out how many atoms that is, if I'm given just 3.98 moles of aluminum, is that within a molecule? The answer is no. A molecule needs at least 2 different atoms, or 2 atoms. So in that case, we would bypass the molecule and go straight to the atom. If we did that, what would we multiply the number of atoms by? Avogadro's number again. Okay. However, and it's not dealing with this problem, we'll do it later here in a second, but if we need to bypass molecule because we're just given an atom amount, then don't go through molecule. All right. However, this is all the question's asking. And did anybody get a number for that? Anybody get 2.40?
Yep.
Times 10 to the what? Good. And that is molecules. Now, if you want to abbreviate molecule, I'll let you go molk here. Okay. Or even that way. Just make sure you have mole with a C somewhere on there. Okay. If you need to abbreviate molecule. This question says how many atoms, so we're looking for how many atoms of chlorine, of Cl, are there in 0.205 moles of what? Phosphorus trichloride. How do I write that? PCl3, good. Okay. So we want to know how many atoms are in 0.205 moles of PCl3. Okay. So what do we start with? What we know, good. So we're going to start with our 0.205 moles of PCl3. Okay. What do I need to convert the moles to? Okay, so 1 mole on the bottom of PCl3. But what goes on top? Molecule, good, because it is a compound, so I need to go through molecule before I can go to atom. So 6.02. And what's really important, you will only use Avogadro's number 1 time within a problem. Okay, really important. Only use this value 1 time. So when you go from here to here, you'll multiply by Avogadro's number. When you go from here to here, you will not multiply by Avogadro's number. Okay. So if we stopped right there, we'd have our molecules of phosphorus trichloride. What do we do next to get the atoms? 1 molecule on the bottom, good. Because what we want to do is we always want to assign the value 1 to the larger of the 2 units. So if I look at a molecule of PCl3, is that bigger or smaller than an atom of chlorine? Bigger, much bigger. So 1 molecule of PCl3, and then this is atoms of chlorine. So what value am I going to put there? Why?
Because there's 3.
Good, there's 3 in the compound. What if I had atoms of phosphorus?
1.
Yeah, 1. What if I just had atoms? Before, yeah, so just count them up. All right. So if it's being specific, make sure that you pay attention to that. So you may need to box in what the question's asking. So molecules cancel, we're left with atoms. And let's see how good you guys are with this.
No.
3.70. 23rd?
Yeah.
Good. And that's atoms of chlorine.
Wait, what number are we doing?
Let's do number 16. So we have 4.87, what is that, kilograms?
Oh, dude, we do.
Okay? And what is the question asking? Number of atoms. Very good. So it wants to know number of atoms. And in this case, all of them. Good. So how do we start this? Good. Start with what you know. Okay, so we're going to put kilograms down here and grams on top, correct?
Yep.
Which one's bigger?
The kilogram, so 1.
Good. So we always assign the larger of the two values, the value 1. How many grams in a kilogram? 10 to the 3, right? Good, or 1,000. And then what? So we're going to have grams down here, but we're going to need a value. So before we do that, let's write what we should have up here. Mole of what? Mole of what? And it's probably a good idea to write that so that you know what the mass should be down here. So mercury has a mass of 200.59, right?
Sure.
And then fluorine, we have 2 of those, so times 19 grams. Okay. So now, if we add these masses together, they'll cancel, grams will go away, and we're left with moles. What do we do now? Need mole again on the bottom. What number are you going to give it? 1. Anytime it's within the problem, give it a 1. And what goes on top? Molecule. That's a 9. Yeah. Okay, so we're going to put 6.02 times 10 to the 23 molecules on top, right? Write small. Then what? 1 molecule on the bottom. Three what? 3 atoms. Very good. And there are 3 atoms in HgF2. That's where I got the 3 from. It's not asking for the number of fluorine atoms. It's not asking for the number of mercury atoms. It's just asking for atoms. Yeah,
Can't we just look at it and put that?
put what?
The 3?
Well, yeah, but you also put everything else. I would hope you'd be able to recognize that there's 3. But since I have 4.87 kilograms of this stuff, I guarantee I have more than 3 atoms. So let's see what your calculator. Yeah, Cal.
So, it just says how many number of atoms, you just, when you're writing that, you just put how many atoms are total.
Yes. 3.68.
Oh.
69. Sorry, 69. So 3.69 times 10 to the 25 atoms. Now, does everybody know how to type this in? Okay. Take everything on top, multiply everything on top, hit your divided button. Okay. Once you hit divided by, open up that parentheses. 200.59 plus 2 times 19, close it, then hit equal. Okay. So anytime you have anything down here, just automatically open up or hit the division sign, open up your parentheses. Okay.